What's up there, guys? Really excited. My first recording so far for you guys. Pretty excited. So, we're going to be moving into chapter 10, and this is going to be all about area. So, solving area. We're going to start with quadrilaterals, triangles, stuff that you guys have probably already seen, and then we're going to move into some little bit more difficult things later on in the chapter. But stay tuned for that. Let's get into this. It's going to take a little while to get used to talking to you guys as if you were here, even though there is no one here. All right, so I'm looking forward to tutorial, or not tutorial. Again, I'm saying tutorial just because you think tutorial and you think online. Anyway, lesson coming right now. Okay, welcome back, guys. This is going to be lesson 10.1, first lesson in chapter 10. This was on page 616, and we're going to be talking about areas of parallelograms and triangles. Okay, and I should mention as I'm going through these, even if you think I'm moving quickly, like if I just leave this up here, I write it and I zoom on to the next page, be a good idea to pause. If you need to wait, you can't do that in the classroom. So this is kind of neat, you guys. If I'm moving too fast, you guys could just go ahead, pause that video and catch up. So let's move on to the lesson. So things we're going to need, we're going to be going over formula for area of a rectangle, area of a parallelogram, and area of a triangle. So let's start with rectangle. So area of a rectangle. Okay. Hope we all remember what a rectangle is, or at least what it looks like. It is a parallelogram. Okay. There's 4 right angles, and if we are trying to find its area, we have a base, we have a height. I think everyone remembers area is a base times the height. So whatever the length of the base is times whatever the length of the height is. And remember, since we're talking area, it's not in units. We have squared units. So squared units signifying it's an area. We have a length times a width. So we have a unit squared there. We also have parallelograms. So area of a parallelogram. Okay. The formula is not different, but a parallelogram actually has the same formula. Formula is not going to be different. If you remember about a parallelogram, it's a quadrilateral, meaning it has 4 sides. So all parallelograms have 4 sides. And then the only thing required for a parallelogram is the 4 sides, and then the opposite sides are parallel. It's been a while since we've dealt with figures. If you remember those arrows signifying that, okay, these 2 here are parallel, and then these 2 here, sides are parallel, so that's a parallelogram. And I mentioned the formula is going to be the same, except when we're talking about height of a parallelogram, okay, if this is the base, this perpendicular distance is the height here. Okay, so we have a base, we have a height. This side length here is not the height if we're using this here as the base. Okay, it's always a perpendicular distance from one side to its opposite side. That's how we're going to talk about height for a parallelogram. Okay, so again, the area for that, base times height, units squared. And then area of a triangle. Okay. Area of a triangle, this is very similar. Okay, we do need a perpendicular height, okay, also called the altitude in a triangle. Okay, we take its base times its height, and this is one I'm for sure you guys know. We divide that by 2, so 1/2 the base times the height units squared. Okay, so that's the area of the triangle right there. 1/2 base times height. So that's all the meat of the lesson as far as what's required. Let's do a couple examples. I know you guys, if given a base and a height, can simply find an area, but let's try a different problem that you maybe haven't seen. So let's go over this thing. If you're wondering what I'm doing, the video didn't freeze, I'm just getting a picture. All right. Our first example. Okay, so what we're trying to do in this picture, this distance here, this height, okay, directions are to find h. Okay, so there's a couple different things. Okay, we need to look at this height here. Okay, what we're trying to find. Okay, we want to find this distance of DE. Okay, this height goes with this base here. Okay, because we have this base AB and we have this height h. Okay, now it's kind of weird. You have to kind of tilt your head to see it. But if we were to turn this parallelogram on its side so it was flat on AD here, okay, the height is no longer this distance here. The distance from this side to its opposite side, and remember what's opposite of DA, this is CB. Okay, distance from here to CB is actually this perpendicular distance here, 9. Okay, distance from this base again to this base is 9. So I can multiply 13 by 9 to get the area, just like I could multiply 9.4 times h. And that's exactly what we're going to do. So if I want to find the area, we're going to take 13, multiply that by 9. Okay, everyone get your calculator out. Although this is what, 90 plus 27? 13 times 9, 117. Remember, this is area, so this is in inches squared. But we're not asked to find the area, we're asked to find h. Okay, so I did 13 times 9 to find the area. Now, I should be able to multiply this base here by this height here to get the same answer. This 9.4 times 8 should also give me 117. So I can use that to my advantage. We'll say 9.4 times h equals 117. Okay, then I should be able to just divide by 9.4 here, and that will give me my h. So what is 117 divided by 9.4? This is about 12.4. Okay, about 12.4. So that's what we're going to say h is. And this is the height, so this is in inches. Okay, height is in inches. Right. So that's my first one. Okay, we're just going to do one more together because I'm probably running over on time because we're supposed to try to keep these short for you guys. Let's try one more. Okay, taking another picture. Okay, this is kind of what we call like a compound figure or a regular figure. So directions here are to find the area. Find the area. So we have a square and a triangle combined. Basically, all we're doing is we're going to find the area of this triangle. Okay, find the area of this square. If we add those together, that is the area of the total house-shaped figure. Looks like a little house TP. All right, so first let's do the square. This guy here. If I want to find the area of, I'll use a little subscript for square here. Okay, area of the square. It's the same as a rectangle, base times height, or s squared, because the side lengths are the same. That's 6 times 6 in this case, which is 36 inches squared. Now the area of the triangle, Okay, that's here. If you remember what these little marks mean, if this is 6 inches here, everything else with a little mark is 6 inches, including this base of the triangle here. So we have a 6 times the height is 8, but remember we need to take half of that. So half of 6 times 8, that should give me, what is that, 3 times 8, is that 24? It's 24 inches squared. And then what do? We take the area of the triangle, area of the square, add those together. So take, say, the area of the total, a little subscript. So the total area is 36 plus 24. Should put me right there at 60 inches squared. 60 inches squared. So I hope this was fun. Usually I ask questions. That's what I feel like I need to do, but I'll be looking for your questions online. Let me know if you guys struggle with this. Homework will be coming to you on this tomorrow. Hope you guys enjoyed this. This was a little awkward for me, but I think it'll get a little bit easier. Fun and exciting stuff. So what a time to be alive. I will catch you guys later.